to understand. Decimals that repeat that are not terminating would be such. Okay, here's an example, just so you know what we're talking about. Repeating means they go on forever. Non-terminating means they never stop. Okay, and we already know some of these. Some examples of that are 0.33333. You could write that forever and ever. We don't. We just do 0.3 with a line over it, and that tells us it repeats and never stops. Another example is 0.16. Okay, those sixes are going to keep going on forever and ever, and they will never stop, but we just write that as 0.16. The deal with repeating, non-terminating decimals is that they always have come from some fraction somewhere. Okay? They can be simplified or changed into a fraction. You can make them into a fraction. Now, at this point, what we've done so far is every time you come up with one of these, I just tell you to kind of cheat a little bit and look at your handy dandy little reference sheet that you have, right? That little thing that has there. I'll bet both of these show up on there, right? 0.3 repeating is the same as
16 and 1/3.
33 and 1/3.
33 and
I'm not doing percents, I'm doing fractions.
But 1/3.
Okay, this is the same as 1/3, and 0.16 is the same as
1/6.
1/6. And the deal with that is if I took 1/6, if I took the 6 and divided it into the 1, this is what I'm going to get. I get 6 goes into 10 once, you get 40, and then 6 goes into 46 times, and you're going to keep getting 4s, and that's where that comes from. Okay? These, ladies and gentlemen, are what we call rational numbers. And I only tell you that because if you come up with non-repeating, non-terminating decimals, if they're decimals that don't repeat and they don't ever end, those numbers are the irrational numbers. They don't make sense to us because they never stop and we don't know what they are. There's not a fractional equivalent to those. Pi is a good example. Pi never stops, never repeats. Okay. Other things that never stop and repeat are, does anybody know? And really the only way you figure this out was the calculator. The other numbers that don't stop, which we call irrational because we don't understand how they can never stop, they go on for forever, are, Alex? Square roots that don't work out. If I were to punch in, did we do this already? I don't know. If I were to take my handy calculator and punch in a square root that doesn't work out, like square root of 4 is 2, so that works out, square root of 9. If I take and punch in 7, which doesn't have a square root, and put square root in there, okay, I get this thing here, digits that don't repeat, and they stop here only because my calculator face point allows that many digits. Okay, if you were to sit down and could do it mathematically on paper, this would keep going forever. The square root of 7 never works out. It's a decimal that never ends. It never repeats. Same thing with any square root that doesn't work. Square root of 3 never ends, never repeats. Square root of 6, all of those things. So those are the irrational numbers. But today we're just talking about the rational ones. Now what we have to look at is something that looks like this. What if you don't have your reference sheet and you don't have the number that shows up on there? For example, if I gave you 16, I'm going to do a percent. If I gave you 16 2/3%, okay, and I asked you what fraction does this equal? Because it does equal a fraction. It does equal a decimal, okay. The decimal would be probably easier to understand because what would be the decimal? You should be able to change it to a decimal. And here's, this is the easy way to think about it. First of all, before you change this, think about what this is as a decimal. What is 2/3 as a decimal? 0.6 repeater, right? So you could change this to 16.6%. And then how do I change a percent to a decimal? Anybody? How do I change percent to a decimal? Any percent can be 80% changed to a decimal, 50% changed to a decimal, 30% change. Sam?
Move the decimal smaller.
Just move this decimal back 2 places. So this would equal 0.16, actually it ends up being 0.16 repeater. Which we know what fraction it is. What fraction was that? We already had that. Wasn't that the 1/6 fraction we just had? Wasn't that 1/6 on the other side? But what about a number like this? Let me find a different one. 41 2/3%. If I have 41 2/3% and I want to change that to a fraction, I'm going to do it here because I like to do it big. 41 2/3%. What if you have that and want to change it to a fraction? Anybody suggestions for me? Ashley?
First change it into a decimal. So, wait, I mean, like 41.66.
No, that's not what I was going to say. You probably could do it that way, but then you're going to get 0.416 repeater, and do you know what that is as a fraction? Okay,
Wait,
I understand what you're thinking, but it's probably not going to work out too necessarily good that way.
Oh.
Ava?
Change 2/3 into the decimal.
Okay, I still have 41.6% though.
And then
And this is what Ashley said that too. 41.6%. Then I could change it to a decimal and I get 0.416. That's my decimal, but what fraction does that equal? What was that? Make a noise, or is that just me? What fraction is 0.416? Actually, but this repeats, right?
I know what
Remember, the 6 keeps going on forever though. Kendall?
You multiply 41 times 3 plus 2 and then you make it like an uneven fraction.
Hey, that's the right first step. But what does that do to me though? That just gives me a percent fraction, doesn't give me a fraction. Well, let me just tell you. Here's what you need to do. Remember what percent is. What is percent? Out of 100. So you really have this, and it looks a little weird, but it actually works out okay. You have 41 2/3 out of 100. Doesn't that look nice?
2.416.
We're not putting a decimal there, just hold on. Check this out though. But what you have to remember is usually we don't write it like this. Usually we write it as 41 2/3 divided by 100. 41 2/3 divided by 100. How in the world would I ever do that? Improper fraction. 3 times 41 is what, 123? 125 over 3. I'll just speed up the process here. How do I divide by 100? I'm sorry, that should have been a 3. How do I divide by 100 over 1? Flip and multiply. Thank you, Nicole. Times 1 over 100. Does anything cross cancel?
No.
Yeah,
Yes.
100 into 125. What goes into both of those?
5.
Let's go
25.
25. See if we're saying something.
25.
25 goes into 125.
5 times. 5 times.
25 goes into this 4 times. So you end up with 5 times 1
5.
over 3. This was a 3.
3 times 4 is 12. It's
Wait,
512.
41 2/3% is the same as 5/12 as a fraction. I don't know.
I hope not.
Well, let me give you. It's not as bad as you think. Let me do it again.
Why are you paying attention?
If you're changing that to a fraction, just work with me here, because the first time you do something is always confusing. Correct, Caroline?
Taking that back to where you did it.
Yes. Actually, it's better if you come back and do it the next day as well. Okay, so step number 1 is put it over 100. Which means you have 83 1/3 over 100. Step 2, this could be reversed, make improper. 83 1/3, 3 times 83 is what? 249, 250. 250 over 3, and that's all over 100. Step 3, make it a division problem. Which means it is what? 250 over 3 divided by 100 over 1. Step 4, flip and multiply by the second fraction. So this changes to 1 over 100. And they usually work out nicely if it's any kind of a fraction. What number goes into 250 and 100? 50. 50 goes into this 5 times and into this 2 times. What fraction do you end up with? 5 times 1 is 5. 3 times 2 is 6. Again, the math part isn't hard, it's knowing that you have to do that that might be hard. I don't know, and time is quickly leaping by. I do have to do one more thing. Take out your notes under exponents.